We often think of crypto as this force of nature, these digital ledgers that just keep going no matter what. Immutable, unstoppable.
Right. That's the common perception.
But here's a surprise, maybe. Sometimes someone can actually hit pause.
Exactly.
So today we're taking a deep dive into this reality of paused crypto projects. We want to look at the times it's happened, often to shield users, what that tells us about the tech itself, and maybe peek under the hood a little bit at how these pauses technically even happen.
Yeah, it's a fascinating area because while the blockchains themselves, like Ethereum or Solana, are designed for continuous operation, the smart contracts built on top of them, they often contain these mechanisms to temporarily halt specific activities.
Yeah.
So our goal today is really to understand why this pause capability is there, maybe what it reveals about the current state of crypto development, and the basic technical ideas that allow it.
And we've got a good set of information to explore this, right? We're looking at things like official documentation. This WP smart contracts explanation of a pause function seems pretty direct. And we also have these detailed analyses, of possible contracts, security incidents from folks like Immune Bytes and Halborn.
Yes, they provide some great technical context.
Plus, we've pulled together some real-world examples, some pretty dramatic ones, actually, where these pauses happened after major hacks.
Yeah, unfortunately, there are quite a few of those.
So for you, the learner, our mission here is to give you a clearer picture of this, crucial aspect of crypto, moving past just the headlines to really grasp the underlying realities, but, without getting totally bogged down in super technical jargon.
Absolutely, making it understandable.
Okay, so let's unpack this first bit. When we say paused in crypto, what are we really talking about? Is the whole thing stopping?
Yeah, that's a key distinction. We're definitely not talking about the entire blockchain network, like Ethereum itself shutting down that keeps running, processing transactions.
Right.
The pause we're discussing is usually a function built into the code of individual smart contracts. So think of a specific DeFi app or maybe a particular token contract.
Gotcha. So it's specific to that application.
Exactly. It's a deliberate feature programmed in to temporarily disable certain functions or actions within that specific contract.
So it's more like hitting the brakes on one particular car on the highway, not shutting down the whole highway.
That's a good analogy, yeah.
And the WP smart contracts documentation, it even shows a pause button, like right there in a wallet interface next to transfer and burn.
Visualizing it.
The process they describe seems almost simple. Log in with MetaMask, click pause, apparently twice, maybe for confirmation, then confirm the transaction on the blockchain.
Well, from the admin side, it can be designed to be fairly straightforward to trigger. But the important part, also mentioned in that documentation, is the idea of pauser roles.
Ah, okay. Roles.
Yeah, and the ability to add pauser role or renounce pauser role. This is critical because it tells you the ability to pause is usually permissioned. It's controlled.
So not just anyone can walk up and hit pause on a major protocol.
Definitely not. It's typically restricted to the contract owner or maybe a small group of designated administrators or even a decentralized governance process in some cases.
Okay, that makes sense. Which leads to the next question. Technically, how does this work? What's the actual mechanism inside the code?
So the core mechanism often boils down to something pretty basic in programming terms. Think of a simple on-off switch.
Okay.
In code, this is often a Boolean variable. It can only be true or false. And the insights from Immune Bytes and Halborn both point to this, often calling the variable something like is paused.
Right, is paused, like a little flag inside the contract.
Yeah.
But how does just having that flag actually stop things?
Good question. So within the functions of the smart contract that users interact with, things like depositing funds, withdrawing, making a trade, the developers put in a check.
A check.
Yeah, a little piece of code that looks the value of that is paused variable before doing anything else. If is paused is set to true.
Then the function just stops.
Exactly. The function is programmed to basically halt, refuse to execute, maybe return an error message. The transaction effectively fails or is blocked at that point.
It's like a gatekeeper in the code then. If the paused sign is up, the gate just doesn't open.
Precisely.
And that Halborn analysis you mentioned, it had that code snippet. That really helps clarify it. There's like a set paused function, probably only callable by the owner.
Right, restricted access.
That flips the pause variable. And then in the user functions, like withdrawal money in their example, there's that line, require paused equals false. That's the gatekeeper check.
That's it, exactly. The require statement checks the condition, and if it's not met, if paused is true, the whole operation stops right there.
Makes sense.
And Immune Bytes mentions there are a few standard ways developers put this in. That global Boolean variable is the most direct way.
Okay.
Another really common method is using pre-built code libraries, like OpenZeppelin's pausable.sol contract. It's like a template that provides this functionality.
Sort of off-the-shelf pausing code.
Kind of, yeah. Well-audited, standardized code. They also mention you can sometimes add controls to, like, permanently disable the pause function later if a project wants to commit to never pausing again.
Interesting. And it sounds like hitting pause isn't always a human pushing a button in a panic, right? That Open Zeppelin video on Pause Guardian suggests automation.
Yes, that's becoming more common, especially for security. Tools like OpenZeppelin Defender can monitor the blockchain for specific, potentially dangerous events.
Like what kind of events?
Maybe a sudden, unusually large transfer of tokens out of a protocol or a rapid drain of liquidity, things that look suspicious.
And the tool can automatically trigger the pause.
Exactly. Based on preset rules, it can automatically call that setPaused function using a secure mechanism, often involving what's called a relayer and specific role-based access controls. It allows for a much faster reaction time than waiting for a human.
Wow, okay. That's pretty sophisticated. But I think, the real impact of this stuff hits home when we look at the actual incidents. When has this big red button actually been pushed in the real world? Our notes are just full of examples.
They really are. And these aren't theoretical edge cases. This mechanism has been used repeatedly, often, as you said, in direct response to some very significant security breaches.
Yeah.
It's a real-world tool.
Let's talk about a recent one. CEDUS, May 22nd, 2025. The reports say a hack over, $250 million?
Yeah, a massive amount.
Which led to them pausing their smart contracts almost immediately. And this was on the SUI blockchain, but apparently the attacker bridged funds to Ethereum too.
That's right. It really shows how interconnected these systems are and how attackers try to move funds across chains. Pausing was a necessary first step to stop the bleeding.
And CEDUS is far from alone. You mentioned Poly Network back in 2021. That was huge.
Astronomical. $610 million exploit across multiple chains.
Yeah.
They had to pause network operations to try and negotiate and recover funds.
And Ronin Network, the bridge for Axie Infinity, in 2022, another giant one.
$625 million. Again, the bridge was paused immediately after the exploit was discovered to prevent further losses.
The list just keeps going. Nomad Bridge, $190 million exploit, followed by a pause. WazirX, just this year, $234.9 million hack linked to the Lazarus Group.
Leading to suspended withdrawals and trading, which is effectively a pause from the user's perspective.
Right. Badger DAO in 2021, $120 million gone from a front-end attack, then they paused the contracts.
And Euler Finance in 2023, nearly $200 million via a flash loan exploit.
Yeah.
They paused too. Though in that case, remarkably, the funds were eventually returned.
That's right. That was a rare positive outcome after the initial shock. So these examples really highlight pausing as that emergency brake after a disaster.
Absolutely. It's often the first critical step to contain the damage.
But it's not only about hacks, is it? Some pauses seem more preventative.
That's a really important distinction to make, yes. The pause function isn't just for emergencies after the fact. It can be a proactive tool.
Like DYDX in 2021, they paused deposits because they found a bug themselves.
Exactly. They spotted a potential issue before it caused major user losses and used the pause function to safely deploy a fix. That's responsible risk management.
Or Bancor in 2022, pausing their impermanent loss protection feature because of extreme market volatility.
Right, managing protocol risk based on external conditions. And Compound Finance had that incident where they paused CMMP token distribution because a bug was causing way too many tokens to be given out.
So preventing further damage from an internal bug, not an external attack.
Correct. It shows the flexibility of the mechanism.
And our deeper dive turned up even more names. Paraluni, Quibbit Finance, Wormhole Bridge, BZX, SushiSwap. It seems like this happens quite a bit across all sorts of DeFi projects.
It really does. It gives you a sense that this is becoming, or perhaps always has been, a standard part of the DeFi security toolkit, for better or worse.
Which brings us to the big question, really. What does all this mean for crypto? This ability to just stop something that's often sold as unstoppable.
Yeah, this really gets to the heart of a major ongoing debate in the crypto space. It's this fundamental tension, isn't it, between the ideals, decentralization, immutability, censorship resistance, and the practical realities of building and securing complex systems that handle, billions of dollars.
It feels like a direct contradiction sometimes. If someone can pause it, is it truly decentralized? Who holds that power?
And that's the core philosophical issue people grapple with. The promise of crypto, for many, is that permissionless nature. The idea that a central party can intervene feels counter to that ethos.
Definitely.
But then, you look at the practical side. When hundreds of millions of dollars of user funds are actively being drained, the ability to hit pause becomes incredibly valuable, maybe even essential.
You can see why teams build it in.
Right. As Immune Bytes and Halborn both stress, pausing limits the immediate damage from hacks. It buys crucial time for developers to analyze the situation, develop a fix, and coordinate a response. It offers a level of control in a crisis that would be impossible otherwise.
So it's a trade-off. You sacrifice some of the pure decentralization ideal for pragmatic security and the ability to protect users.
That's often how it's framed, yes. A necessary evil, perhaps, in the current stage of development.
Are there downsides to having this pause capability beyond just the philosophical conflict with decentralization?
Oh, absolutely. There are real potential drawbacks. Immune Bytes brings this up. The very existence of a pause function can sometimes damage user trust.
How so?
Well, if you know that the team or even a single person can freeze your funds or stop you from using the service at any moment, you might be hesitant to deposit large amounts or rely on it long term.
Yeah, I can see that. It introduces an element of uncertainty.
Exactly.
Right.
It creates a perception of centralized control, even if the team's intentions are good. And if pauses happen too often or aren't communicated well, it could definitely discourage people from using dApps altogether. It makes them feel less reliable than traditional systems in some ways.
That's a good point. If your bank suddenly froze withdrawals, even for a good reason, you wouldn't be thrilled. So how do projects try to address these concerns? How do they make the pause function less centralized, maybe?
There are a few approaches. One idea Emites mentions is using time-locked pauses. So the pause might automatically lift after, say, 24 or 48 hours, unless further action is taken. This limits the duration of control.
Okay, so it can't be paused indefinitely without more steps.
Right. And probably the most common and important method, highlighted by both Immune Bytes and Halborn, is using multi-signature or multi-sig control.
Multi-sig, meaning multiple people have to agree.
Precisely. Instead of one owner key holding the power to pause, the control is distributed among several key holders. A certain threshold, maybe 3 out of 5 or 5 out of 7, needs to sign off on the transaction to actually initiate the pause.
Ah, so it distributes the trust and makes it harder for one person or one compromise key to halt everything.
Exactly. It adds a significant layer of decentralization and security to the pause control itself.
This whole topic gets me thinking about, well, maybe more speculative things. Does this reliance on pause functions, this need for an off switch, suggest something deeper? Like maybe some of these complex systems are held together by, I don't know, shoestrings in ways we don't always see, unexpected single points of failure.
That's a really interesting way to put it. I mean, pause functions exist because exploits do happen, right? It acknowledges that smart contracts, even after audits, aren't foolproof. So yes, the need for the pause function definitely points to inherent vulnerabilities still present in the space.
And the control itself.
And the control itself, especially if it's not a robust multisig, does represent a centralized point of intervention. While it's meant for safety, you could argue that the owner-controlled pause is, in a way, a critical switch, a potential point of failure if that control is misused or compromised.
Almost like a dead man's switch. Not literally, maybe, but in the sense that if the controller disappears or gets hacked or makes a terrible call, they could effectively stop the whole thing, right? That WP Smart Contracts doc mentions contracts ownership. That ownership implies this power.
It's not quite the classic dead man's switch that activates on inactivity, but the analogy of a central control point whose failure or compromise could lead to a system halt.
Yeah, it holds some water in certain scenarios, especially with poorly managed keys. It underscores why transparency around who controls the pause function and how is so important for users. You need to know where those potential switches are.
Yeah, absolutely. It also makes me wonder about other ways to control things, maybe more subtly than just a full stop. That ArcSpeed paper we looked at mentioned other kinds of temporary restrictions.
Right. That research gets into more granular controls. Instead of a global pause, you might restrict how often a specific function within the contract can be called.
How would that work? For example, you could limit a function to being called only once to a transaction, or maybe only once per block, or only allow a certain number of calls within a given time period, like an hour.
And why would you do that? What kind of problem does that solve?
Well, think about flash loan attacks. Some of them rely on making multiple calls to manipulate a contract within a single complex transaction. A restriction like only one call per transaction could potentially block that specific attack vector.
I see. So it's a more targeted defense than just shutting everything down.
Exactly. But these finer-grained controls often come with their own trade-offs. They can make the contract code more complex, potentially more expensive to run in terms of gas fees.
The transaction costs on the blockchain.
Right. And sometimes these restrictions might interfere with how the contract is supposed to interact with other contracts, what we call composability. So it's a constant balancing act developers face, finding the right security measures without crippling usability or efficiency. It shows there's still a lot of innovation happening in this area.
Okay, so wrapping this all up then, it really seems like, while we love the idea of truly unstoppable crypto, the practical reality, at least for now, is that this ability to pause functions in smart contracts is, well, it's become a vital tool. Maybe a sometimes concerning tool, but vital for protecting users and their money when things go wrong.
I think that sums it up well. Understanding these pause mechanisms, the why, the basic how, and the history of when they've been used, it really empowers you, the learner. It helps you look at projects with a more critical eye to understand the trade-offs being made between pure decentralization and practical security.
It moves you beyond just the marketing hype, maybe.
Hopefully, yes, a more informed perspective.
And it definitely leaves us with a big question to ponder, doesn't it? Given that we've seen this repeated need for these kinds of breaks, what does the future look like for truly decentralized, truly unstoppable systems? How do we get to a place where security is so robust that intervention like pausing isn't considered necessary? Or is it always going to be a necessary compromise?
That's the multi-billion-dollar question, isn't it? How to achieve that perfect balance. It's something the entire space is working towards, experimenting with, constantly evolving.
Definitely something to keep watching. Maybe you can dig into some security audit reports for projects you're interested in, see who holds the pause keys, or research some of these specific incidents we touched on. Lots to explore.
For sure.
Well, thanks for taking this deep dive with us today.
My pleasure.